Okay, we're live.
Good afternoon, everyone. I'm David Osborne. Yes, we're live, Tim. Yes, good afternoon, everyone. This is Sustainable Aurelia, and this is another webinar in our series of webinars for Sustainable Aurelia Month. On the screen is a letter from our president, Stan Mathewson, saying that he's pleased that you have chosen to join us to go over some of these very key issues. At this point, I would like to turn over the webinar to our official host, which is Tim. And Tim Adamson is going to talk to you about some of these issues. Go ahead, Tim.
Okay, thanks very much, David. But before we get going, I would just like to acknowledge Indigenous rights. We acknowledge that we're on the traditional territory of the Anishinaabe peoples. I wish to recognize the long history of First Nations and Métis people in Ontario and show respect for them today. I would also like to specifically acknowledge the neighboring communities of the Chippewas of Georgina Island, Chippewas of Rama First Nation, and the Beau Soleil First Nations. So with that recognition, it's my great pleasure to introduce Kerry. Kerry, I want to thank you very much for coming to this webinar on energy storage this afternoon. We're very lucky to have Kerry to join us today to explain what energy storage is about and how this technology can fit in with a sustainable energy future for Aurelia. I've known Kerry for about 15 years when we both worked at Enbridge, and I know she brings a wealth of experience today. If Aurelia is to survive economically as well as socially, we all need to start thinking about what our energy future is going to look like, not just for residences, but for our commercial and industrial businesses as well. There's no one magic bullet to save us all, but it'll be a mix of solutions. Energy storage is just one of those options. And it's so important that I think Kerry will call it the Holy Grail. So I'm going to let Kerry explain what this is all about. If you've got questions, just put it on the chat line on the right, and we'll try and answer them as we go along. So Kerry, on behalf of us, thank you very much for being here, and over to you.
Great. Well, Tim and David, thank you so much, and to Sustainable Aurelia. It's great to be part of the conversation and to support the Sustainability Month and the ongoing webinars that you're kindly hosting. I'm going to just go ahead and share my screen, and let's put up the presentation. Okay. And you should see a presentation, Tim. Maybe you could just kindly confirm energizing Ontario's electricity sector with energy storage.
Yeah.
Okay, wonderful. All right, well, it's all good? Yeah. Okay, great. I'm just going to jump right in. So what I'm going to be talking about for about the next 20 minutes is about energy storage, setting the context to understand how the electricity grid is changing, the promise of energy storage, what is energy storage and how does it work, and then we'll be peeling the layers of the onion back a little bit more to talk about what is Ontario's electricity grid, what are the benefits of adding storage to Ontario's grid, and then, you know, kind of going even further, how commercial and industrial customers can really benefit, particularly around their electricity costs, but also how energy storage with what we call double conversion UPSs can improve power quality, reliability, and resiliency. And then we'll be sort of finishing off about a 20-minute presentation with a discussion on something that I'm very excited about, the use of energy storage to help with Nonwire Solutions. And I'll get into a little bit more about what that's all about. And so I encourage you to kind of write in your questions in the chat function. And Tim's going to try and stop me as I present if there's something burning. If for some reason, I miss a question, we'll definitely get to them at the end of the presentation. And so with that, let's sort of dive right in. And I'm just going to start with a little bit of the obligatory slide about my company. So I'm the Vice President of Regulatory Affairs and Investor Relations at Storage Power Solutions. We're a proud Canadian company. We've been around since 2014, and we design, manufacture, and distribute lithium iron phosphate-based battery energy storage systems. And our storage systems, they're really designed for a variety of different applications, including double conversion UPSs to help customers reduce their energy costs while providing high quality power. And what we really bring to the conversation on energy storage is about 100 years of proven experience in power electronics, energy storage, UPSs, and renewable energy. And we've certainly got a good track record of deploying over 1.5 gigawatt hours of energy storage and about another 4.5 gigawatt hours of critical infrastructure. I think in a nutshell, our vision is to provide 100% reliable, low-cost, clean power for all by enabling the grid of the future. So that's a little bit about Storage Power Solutions. So just want to dive in a little bit about setting the context and how is our electricity grid changing? We are coming from a long history of a centralized grid with centralized generators, long distance transmission, and local distribution companies. And that's worked really well for a long time. That model is now evolving to one where we have distributed energy resources. And what that means is that we've got generations located much closer to the customers and the load requirements. And I did put up a little bit of a visual on kind of a comparison between a centralized system and the one where we have more of a distributed energy resource mix. And I think the importance here is that distributed energy resources now make up 10% of Ontario's installed capacity. So it definitely is a growing phenomena. And there have been some really important enablers in Ontario for that. We'll talk a little bit later about technology cost reductions, but there are a number of important policy and regulatory innovations that have really enabled distributed energy resources to really start to take off. And that's things like the Industrial Conservation Initiative, net metering, feed-in tariffs, and microfit. Also, just energy efficiency and some important time of use pricing, as well as some other innovations in capacity and market renewal at the wholesale level. So in essence, there really are an important number of enablers that have really started to move us towards this path of distributed energy resources. And what's really important in a future world of distributed energy resources, and one we call a digital grid, this is where the promise of energy storage comes in. Energy storage is really what we call the glue to help efficiently match electricity supply and demand. So we've got this distributed generation with distributed loads, and energy storage can do a fantastic job of really efficiently matching that supply and demand. And through that, through energy storage, harnessing the power of intermittent and distributed energy resources to help offset fossil-based peaking generation. What we like to say is energy storage promises to be as profound a disruption to the energy sector as the internet was to computers. That's a pretty bold statement. So, you're probably at this point going, well, that's great, Kerry, but what is energy storage? I really don't know what it is. And I'm not going to, I've just prepared this slide more for your background, and encourage you to take a look maybe after the session, and happy to answer any questions, but won't sort of dive into too detailed here. But in essence, energy storage is, simply put, it captures energy produced at one time for use at a later time. And just very quickly, you've got a range of energy storage technologies that are really suited for a particular application. The company I represent, Nonwire Solutions, we're primarily in battery energy storage that uses, chemicals or chemical energy to absorb and release energy on demand to provide dispatchable energy. But you've got other great technologies like flywheels, supercapacitor banks. We've got power to gas, which is really exciting technology because it offers the potential to convert electrical energy into hydrogen, which then can also be blended with natural gas to create RNG, or also to move energy back and forth between the electrical grid and the natural gas grid. So that's a really exciting technology as well. We've also got pumped storage and compressed air energy storage. So we've got a range of technologies, of energy storage technologies, which are really exciting. And the promise of energy storage is, I always kind of liken it to a Swiss Army knife. A Swiss Army knife, it can perform a variety of different functions, and energy storage is the same. It can provide simultaneously multiple grid functions. I've included what we call the energy wheel. This is from Rocky Mountain Institute, and I've seen it in a number of different presentations, probably because it really encapsulates the different services that energy storage can provide, and distributed DR type resources as well. And so on your right-hand side, you've got, in the green, you've got your wholesale services. So energy storage is very well suited to providing ancillary services, capacity and operating reserve. Down in the blue, energy storage can help defer transmission and distribution investments. And in the orange, it is also very well suited to providing customer-related services, such as reducing costs. So this is a great little kind of wheel, and you can sort of dive in and look at the different services. Now, I did mention that energy storage is, a range of different technologies, and they provide different grid services. And this just sort of takes it one level lower to kind of give an overview of the time scale. You've got some types of technology which are really good at sort of real time. The whole electricity system needs something called inertia, which is really like the fulcrum of this system. And things like pumped hydro and compressed air really are great at providing that type of service. Over kind of sub-seconds and seconds, you've got, you're really into fast response type energy storage that are helping to provide those important ancillary services, and also to support things like firming up your intermittent renewables. As you get into minutes and hours, that's where you do start to see energy storage playing a role in helping customers reduce peak demand, providing support to the transmission grid, and also providing important peak capacity services to the grid. And then on the far right, you're getting into days and months, where we're really talking about what role can energy storage play in storing energy over that longer duration to supply a seasonal need. And that's where things like increasingly battery storage, but pumped hydro and compressed air and power to gas play an important role. But I think in essence, what I would take from this slide is there are different technologies, energy storage technologies, that really do play different roles over a different time frame. So I mentioned that one of the key enablers of energy storage has been the decline in technology costs. And that is true of all the technology, energy storage technologies that I highlighted previously. I just sort of put up some information on battery storage. And since 2012, capital cost of battery energy storage has declined by 75% to less than $150 per kilowatt hour installed. And the little infographic there of Tesla, our good friends at Tesla, are showing that they're on track to certainly be below $100 per kilowatt hour by 2023. And certainly from my company's perspective, Storage Power Solutions, we are, very competitive with Tesla at those same price points. So it's not just Tesla. This is really where the market is at and where it's going. So you might ask, well, that's great, Kerry, but what is the implication of that for Ontario and also North America? And really what the key message here is that solar and storage generation is now cheaper to build than new gas plants. And by 2032, probably I would even argue earlier, it'll be cheaper to build and operate compared to existing gas plants. So we really are on the tipping point of a really important energy revolution or electricity revolution. So let's kind of take it to the next level with Ontario. And what I've done here is pulled up the latest IESO planning forecast. So every year they kind of put out a long-term forecast. And this was done late last year. And what it's showing is that while 90% of Ontario's energy mix is non-carbon emitting, we've got a lot of nuclear and hydro and renewables. In the foreseeable future, we are going to be increasingly reliant on natural gas to supply peak energy demand. And what IESO, that's the Independent Electricity System Operator, they're projecting that to increase from 10% to 20%, so quite an increase. So you might ask, why is that? And that's primarily because of things like the nuclear plants. There's a number of units that are being refurbished, as well as we've got certain contracts, long-term contracts coming off contract. So there's a number of changes. But in essence, what we're seeing is increased reliance on natural gas. And that's where energy storage can play a really important role paired with renewables to reduce greenhouse gas emissions by lowering the use of natural gas-fired generation on the margin. And, at the same time, we do have a rising cost of electricity in Ontario. I'm sure, if we look at our pocketbooks, we can clearly see that's the case. The electricity price, and this is just on the supply side, is comprised of your hourly Ontario energy price, called HOEP, as well as the global adjustment price. And overall, rates have doubled since 2009, primarily through the global adjustment. And even this year, with COVID and a lot of things going on, GA has increased by 9%. And for a mid-sized customer, the GA rate can range between 9.9 and 11.5 cents per kilowatt hour. So the GA is very complex. It's also very political. But in essence, it is a settlement mechanism between the hourly Ontario energy price and the things like the regulated rates for OPG, payments to gas-fired and renewable facilities on contract and other nuclear stations, as well as the cost of delivering CDM programs. So as I said, it is complex and very political, but what we do know is GA is going to be going up increasingly in the future. And for a typical customer, it now makes up about 70% of the electricity bill. And that's really, where energy storage can come in. Earlier this year, Energy Storage Canada worked with Power Advisory to commission a study that quantified adding about 1,000 megawatt hours of energy storage can yield between $2.7 and $4 billion of benefits to Ontario's electricity ratepayers. And that was principally through a wholesale market, providing these ancillary services I mentioned earlier, helping to maximize our transmission and distribution assets. And while they didn't quantify it specifically, they also did talk about the direct customer savings as well as being an important part of the value chain. And that's something I'm going to kind of dive into next. So for large customers, there's been increasing, I think, interest and participation in a program called the Industrial Conservation Initiative, which helps customers who have a peak demand of greater than 1 megawatt, and in certain classifications, like manufacturers and greenhouses that have a peak demand greater than 500 kilowatts, they can opt into this program. And if you've heard the term Class A customer, that's really what that sort of signifies, that they are participating in this industrial conservation initiative. And by opting in, a Class A customer has the ability to reduce their electricity costs by as much as 70%, this GA cost, by reducing or eliminate, if they can eliminate their electricity demand during the overall system peaks, top 5 hours, you know, they can stand to significantly reduce their bill, as I mentioned. And we'll get into a little bit about how that works. But in essence, the Industrial Conservation Initiative, or the ICI program as we call it, has been a very effective peak reduction tool. And in 2018, as an example, it delivered about 1,600 megawatts of demand reduction to the system. And that's a really important way. You know, I've talked about the reliance on natural gas, and that's a really important way to mitigate that usage. So how does the Industrial Conservation Program work? So for customers who are greater than 1 megawatt, or as I mentioned, in certain cases, greater than 500 kilowatts, they do have an opportunity every year from May the 1st to June 15th to opt into the program. Prior to that, they do have an important variable set called the peak demand factor. And I'd be happy to, if anyone after wants to follow up about how this is calculated, be happy to do that. But I did put a little bit of a graph, or a table, I should say, on the right-hand side. But in essence, what happens is, for the top 5 system hours, you sum up the system megawatt demand over here, and you sum up the facility's top 5 hours peak demand, and you divide the facility's top 5 hours by the Ontario system top 5, and that gives you something called a peak demand factor. And every month, your global adjustment charge is that portion of the overall GA's costs. So the important thing to, and sorry, that is billed through an adjustment period from July 1 to June the 30th of that year. So again, the sort of key message here is, for customers who are able to reduce their peak demand during these top 5 hours, they do stand to really help the system, but also really reduce their electricity costs. And just to sort of show by a little bit of an illustration, I just put together a little bit of an example of a large office building with a 1.5 megawatt peak, and if they had what we call a 2-hour battery storage, so they're able to store enough energy for a 2-hour period. But just for this scenario, you know, we're pretending it's July the 9th, and the system operator predicts that it's going to be a peak based on their projections. It's going to be one of the top 5 system peak hours at 5 o'clock. So the office deploys its battery storage at that time. So it goes from the blue dotted line to the orange. So they're able, what they're doing at this point is they're relying on their stored energy in the battery. So the system sees that their demand is actually zero. And so they're able to mitigate one of these peaks. And then after the peak hour is over, they do continue on with their sort of regular day and their regular consumption. And but then they do have to charge the battery back up at night during off-peak hours. And so you see before what their demand would have been is increased somewhat to charge up that battery. So how the customer saves is that they do have bill savings by a reduced global adjustment charge that we talked about before through the ICI program. They do actually save on their energy commodity costs, and that's the difference between peak and off-peak hours. And also there are some other opportunities if they are registered as what we call a demand response customer. I do sort of want to point out, this example was put together for illustrative purposes only, and participants are encouraged to seek advice from, professional energy management firm. There have been a lot of customers. We sort of talked about 1,600 megawatts of demand or participants in this program. So it is getting harder to predict when that system peak is going to occur. So it's best to sort of seek that sort of professional guidance and look for a company that can help you put together a holistic program. Energy efficiency, reducing energy use through energy efficiency, I think should always be job one. And then seeing how you can reduce your demand through curtailing or shifting when you use energy. And, if the business case is still there after the fact, to look at demand response, including options like battery energy storage. That's certainly, in that we're certainly seeing a lot of interest in battery energy storage as a result. So some good opportunities for customers. And, battery energy storage, I just wanted to sort of also kind of highlight that, energy storage with double conversion UPS has an ability to provide local power quality, reliability, and resiliency. And, what we're seeing due to extreme weather events and, end-of-life equipment failure from both at the distribution and transmission levels, there are increased outages. And so the way that the double conversion UPS works is it kind of provides all the benefits of backup power and then providing power factor correction, but as well as providing all the benefits of energy storage and reducing energy costs. So it's able to do that by, as I mentioned, correcting power factor, but also, filtering harmonics. So you're taking out all the noise, common mode noise coupling on the line. And the ramp rates are really fast as well. So we do definitely call this a fast ramp rate. And then, I should also mention that because UPS is a one-way, it doesn't feed back into the grid, it does simplify the utility permitting process, which has been a little bit challenging. There are efforts underway to simplify the permitting process for energy storage, but this is a technology that we believe is very promising from that perspective. And the last topic is Nonwire Solutions and the role that energy storage can provide or play in shoring up our transmission and distribution assets by, and cost effectively by deploying energy storage, as well as other types of resources like local generation, demand response, and energy efficiency. If we deploy them locally in that sort of distributed energy resource manner, we're able, in some cases, to either delay or completely negate the need to have to invest in very expensive poles and wires and things like substations. And just as an example, I went on the IESO website. They do have regional energy consultation processes. There is one ongoing right now that includes Aurelia, and they have identified certain end-of-life transmission equipment that needs to be replaced in 2025 and 2028. And so, part of the process is to look at, can things like energy storage or energy efficiency play a role in either deferring or eliminating this need to upgrade these assets? And that's another way that owners of energy storage and other assets can generate revenue. They can be paid by utilities to operate these assets at a time when it's needed, usually when there's kind of a peak load on that transmission and distribution asset. So, in a nutshell, Nonwire Solutions are very sort of exciting, cutting edge, other sort of deployment for energy storage that can really play a role in Aurelia's electricity and energy future. And, so in summary, we've covered a lot of ground today, and I appreciate everyone's sort of patience. Energy storage, what we've talked about, can play a really important role matching electricity supply and demand, and enable intermittent and distributed energy resources to offset fossil-based peak generation. Energy storage, there's a variety of different energy storage technologies out there, and they can provide a variety of grid services to support our electricity system. As we move to a more distributed energy resource model, it's going to be more important than ever to deploy energy storage. And that's really been fueled by the declining cost of energy storage technologies. What we've seen is that through a report by Energy Storage Canada, deploying about 1,000 megawatt hours is forecast to reduce ratepayer costs by between a range of 2.7 to 4 billion. So I think that's, offers a lot of potential for our customers. And we did talk about the role of the Industrial Conservation Initiative as one way that larger customers, greater than 1 megawatt, can participate and use things like energy storage to reduce their coincident peak demand, and help both provide local resiliency and reliability, but also reduce their electricity costs. And finally, we did sort of touch on Nonwire Solutions and the role that energy storage can play in deferring or eliminating the need for transmission and distribution upgrades. And with that, at the end, obviously, there's my contact information. If you have any specific questions or would like me to go through any of the material, happy to do so. And again, just want to thank Sustainable Aurelia for the kind invitation, and just really glad to be part of the conversation to move us towards a more renewable future. And with that, I just want to say thank you very much.
Doing that, there's an awful lot of material there that we need to absorb. I did, for the attendees, on the chat line on the side, do any of you have any questions for Kerry? I don't see anything. No? Did I hear a question? No, the only comment I would have, Kerry, is on the distributed energy resources section. And one of the issues that we came out when I was with the Environmental Commissioner is actually the 10% is actually going to be more than that. There's a lot of generation is hidden from the IESO. So in practicality, it's actually going to be more like 20, maybe even as much as 25%. From a sustainable Aurelia's point of view, we have a vision of much more solar coming into the community. This is just talk that we've got that. So I think, in the period 2025 to 2030, we're looking at significantly more solar. And we're sort of talking about how we can, figure out how that can be implemented. So the storage, will link up obviously with your, you know. So anyway, I have a question here for you, Kerry.
Okay.
And it says, do you see electric vehicles adding to the energy storage picture?
Yes, I think that's if there was a bit of an oversight on my part, it probably was energy vehicles. First of all, I think they are going to be a very important, we call beneficial electrification. So for the electric system as a whole, both increasing both the kind of consumption of electricity, but there's also, if you've heard the term vehicle to grid, this concept that, and particularly with things like software, but for electric vehicles, they are a source of energy storage. And so they can be deployed at the grid edge to also enable, building charging as well. So they could be a very important part of the future. And there's some great work being done by Ontario companies, and I'll give a shout out to one, and my apologies, I know there's probably a few, but Peak Power, for example, they're doing some really important and kind of cool work with OPG on that, but I'm sure there are many others. So thanks for the question, and that was probably a little bit remiss on not talking about that.
What was the name of that company, Kerry?
Peak Power.
Peak Power? All right, okay. I have another question. And as an electric vehicle owner, I'm interested in behind the meter storage as a means of reducing impacts on infrastructure costs. How important will this become in the future, do you think?
I think it's going to be, very important. There are going to have to be some policy and regulatory changes to enable that. Just to illustrate a little bit, but, if you imagine you've got a fleet of electric vehicles charging at home, what we want to put in place is at the rate level, more flexibility for customers and incentives for customers to charge their electric vehicles off peak, and maybe even to provide we call it demand response, but as I was mentioning before, provide incentives to vehicle owners to kind of charge or to give to the grid their sort of electricity from the vehicle. So, electric vehicles are, I think, an important tool in the future, but we've got to really look at the rate structures with Ontario, get that flexibility, get some demand response programs up and running with some of the local LDCs, maybe with, I believe Aurelia Power was recently purchased by Hydro One, if I'm correct, but, I know they're doing some important work in that area, but, if we can get some good demand response programs, I think that's going to be an exciting opportunity for owners of electric vehicles.
Thank you very much. So a question I've got, so if Aurelia is thinking of trying to get a program to deploy much more solar on the residential side, maybe commercial as well, how many buildings would we need to put solar on to implement your battery? I mean, it's probably different battery sizes, but say your smallest battery, just to give us a sense.
Well, that's where I've sort of talked about in the presentation. You've got different technologies, but then you also have different sizes of batteries. When you get into residential energy storage, you know, you kind of think of the Tesla power walls and that kind of thing. There's some great examples of great programs. Green Mountain Power, for example, where, you know, they really enable things like rooftop solar and energy storage. You know, really where Storage Power Solutions specifically, you know, our technology is really around those kind of larger office, university, hospital, industrial kind of applications. But you know, that being said, there's a lot, you know, there are some really good players on the smaller scale as well. And I should say as well, there's some very exciting developments around that was just recently announced called community net metering. And that I think would be of, I would believe, high interest to Aurelia, because it's really allowing community solar, which allows more of a subscriber model, and to enable sharing of electrons between participants in a project. So happy to sort of take that offline with you on that. But that is, I think, you know, a really good model for residential solar and small commercial.
Okay, now that's great. So from a planning point of view, you know, and this is where I'm not sure, if there's somebody wanting to build a larger, you know, 1 megawatt sized building, could be a hospital, you know, educational facility. Somehow in the planning process, when they do that, we need to embed energy storage as part of the very, very basic planning principles. Correct? So what's your recommendation of how we would do that?
Well, it, you know, really has to start at the kind of design level with the, you know, design engineer, as well as the architect. So you have to, you know, it's the same, the true for energy storage, it is for energy efficiency. We've always talked about, you know, when you new construction, you can't sort of, you can add it after the fact, but if you start designing this in as a principle, like keep making room for energy storage, having as a design standard solar, you know, that is going to be much more cost effective down the road. So, you know, involving architects, design engineers, your EPCs, I think is a really important first step. And, you know, companies like ourselves, which are more on kind of the manufacturer, we partner with software providers. But, you know, we certainly have a role to help kind of educate what is possible, what are the technology options, help with the design engineering process. But, you know, that would be my recommendation anyway.
Okay, and I've got another question here from an attendee. How quickly do you see this distributed energy model hitting a threshold in Ontario where it is predominant way of electrification? It is the predominant way of electrification.
Right. Well, you know, if I had a crystal ball and could answer that, I probably maybe politely wouldn't be here. I would be playing the lottery. But you know, it is an interesting question. There's some important work being done by the Ontario Energy Board to really help reduce the barriers, and that includes both in the permitting process as well as some important questions about what our local distribution companies look like in the future. How do they have a viable business model? And I think those are some important questions that, you know, do have to kind of get answered before we can get, you know, sort of fully move to that model. But I think in a nutshell, you know, I would say between 5 and 10 years.
Okay. I won't hold you to that. Okay.
Okay.
That's great.
We'll get a cup of coffee on that.
Thanks to you, you know. Okay, so for the attendees, are there any other questions? I'm just looking at the time here. Nothing? Don't see anything on the chat line here. So with that, Kerry, that was great. So on behalf of Sustainable Aurelia, I really wanted to thank you. Those slides, you put a lot of work into it, a lot of information for us. I really appreciate that. And as we move forward in Aurelia with our visions and plans, I'm sure we'll be talking to you in the future. So with that, I would like to bring this now to an end. And Dave, maybe David, I hand it back to you to shut it off. Once again, Kerry, many thanks.
Thank you, everyone, and to Sustainable Aurelia.
Yeah.